1882, a development happened. Nelson and Plosser, they were as such the one who were the first to question this element of trend being deterministic. If trend is deterministic, you can use the traditional methods, okay. But these two, they questioned, how can you say that the trend is deterministic? And that suppose there is a stochastic shock at some point, if the trend is deterministic, the effect of the shock is short-lived and the series will return to the underlying deterministic trend in a short period of time. That is, the series will mean revert. But they said that trend is not deterministic. Trend is stochastic. Once the shock is there and we go to a certain higher level or a lower level, but we never come back to the same mean which we were earlier having. So this was the first time the notion of the trend being deterministic was questioned. That is, in the stochastically trended series, shocks have a permanent effect. The shock is integrated into the system, and that is why we call it integrated series. Stochastic trend is also called as integrated. The effect of the shock is integrated into the system. This was, they were basically discussing that business cycles. So in business cycle theory, it is the ups and downs, they are caused by real factors, and most important factor is a productivity shock, and the series move away. Impact is felt for a very long period of time. So this paper by Nelson and Plosser in 1982, they questioned the traditional wisdom of deterministic trend for the first time. So now things started. Again in the 80s, another development, this Engel and Granger and Weiss and Engel and Granger in 1983 and 1987 respectively. Now when Plosser said this trend, you are saying, okay, we are using traditional methods to find estimates and we are assuming that the trend is deterministic, but the trend is not deterministic, trend is stochastic, then we are stuck, we cannot do anything. Then came this study. They gave an innovative approach, and what they said, that if two or more integrated series, now we are not talking that it is a deterministic trend, we are talking that the trend is stochastic, that the series is integrated nature. If two or more integrated series which do not have a tendency to move together may be tied together in the long run, they may look as not related in appearance, but they may be tied together. This gave birth to the new thing. This gave birth to a completely new phenomenon, and it is referred to as cointegration. Means, it first of all, it gave an idea. A new theory was developed that even if the series is trended, even if the series is stochastically trended, in that case also you can make meaningful interpretations from the estimated parameters by using the technique of cointegration. Now, if you want to understand cointegration, again, we will read it in coming classes. But see, cointegration, suppose we take a slang type of example, like there is a man who is drunk. You leave him in the park. It's a big, wide, flush green park. You leave him over there. And imagine how the man will behave in that park. Sometimes he will go here, sometimes he will go there, sometimes there, sometimes here, sometimes here, sometimes here, and likewise. This is how the man would move in the park. Random, erratic. But suppose this drunk man itself is having a dog with him and he is holding the leash of the dog, and somehow it is tight in his fist. The dog cannot go off. So the dog will also move along with the drunk man. This is, you can say, a naive example of co-integration. But this revolutionized the concept of estimating parameters from time series data. Nowadays, you cannot imagine that you are doing estimation of data of time series nature without testing for stationarity. You cannot simply doing OLS and giving the estimates, even if the assumptions of classical linear regression model are valid, but still you cannot imagine that nowadays we have to check for stationarity, and if the data is stationary at level, fine. Now, one may question, what is the beauty of this? Okay, see, if this thing is not there, what was the way out? That we can work with integrated series. We could not have worked with integrated series if co-integration if it was not discovered. We could not have, we could not have worked with integrated series. Okay, then although we say whenever we talk about sample and hypothesis and population, and we ignore hypothesis. Whenever we talk about sample and population, the first thing we struck to our mind, okay, we are conducting a primary survey. We will take out of the entire sample of our study, population of our study, we will take a small sample, and then we will test for hypothesis, and we will try to find out whether the sample statistics is equal to the population parameter or not. But we never think, modern time series, they apply the same concept over here also in how the time series data you are getting. They say that when you are estimating GDP, there can be 100 figures of GDP. Out of those thousands and 100 figures of GDP, one figure you are getting. Or if you are again, somehow you are allowed to again do the calculation, you can go back and have a calculation, you will be getting again one figure of GDP. So what they are saying, that time series is also a realization generated by a stochastic process. Particular realization at a specific time point is just one of the possible outcomes. So they say that this GDP is also an result of a stochastic process. Like we say in a particular year, we can get n number of observations, but we take one value of GDP. And suppose the history is repeated, then there will be another value of GDP. This can have infinite time. So one of the elements is, although we do not think in that way, but the thing is, the same thing which is applicable in primary studies where you have studied a sample of the total population, the same thing we say over here. Here also the data is generated through such a stochastic process. The implication of this is, the realizations from a stochastic process for economic data will not stay still and have a tendency to move in one direction. So, for a series, a sustained move in one direction, like there is a mean and likewise. So, the arithmetic mean will not represent any of the mean. This year the GDP is this, next year the GDP is this, then the next year the GDP is this. So the arithmetic mean does not have any, means you will not say the arithmetic mean is a representation of this. We were having, say, around 20, 32 billion dollars, and now we are having 60, 100 billion dollars. So that you cannot say the mean is this. So here you have to understand that it is for a stationary series, x bar cannot be an estimator of mu. So it's not only that you have to study the mean, and mean will give you a representation of the of that series. So that's what we have to understand from this. Again, another concept over here is of random walk. Now we have seen non-stationarity. We are saying if your stock is integrated, we move away and we keep on moving away. It's non-stationarity. But non-stationarity does not mean only a sustained increase or decrease. It also implies a sustained walk in one direction before moving to the other direction. And random walk is one of the suitable examples of random walk are the movements in share market. If you have a look at the stock prices, something like this is happening. You are going up, you are going down, you are going up, going down. So this can also be an element of non-stationarity. So it is not necessary that there is a trend and you go on increasing. A sustained movement in one direction, then again in one direction, then again in one direction. This can also be a representative of a data which is having a non-stationary process. So non-stationary does not mean only trend. Sustained walk in any direction is also mean as non-stationary. The best examples of these are the movements in the exchange rate market and the share markets and all. The next concept which we have over here, spurious regression. We will see there is a very interesting example of it, of a spurious regression. Now, technically, if you understand how to define it, that we have three variables x, y and z. Even if x and y are not related with each other, we get correlation between this x and y because both of these variables are associated with some other variable set. That is, if we regress y on x, we get a significant relationship. When we control for the third variable, the relationship becomes 0. We will come back to we will take this example. A study conducted by Yule in 1926 for the period 1886 to 1911, it studied that the dependent variable was the number of marriages conducted by, the dependent variable was the death data, how many people are dying, and the independent variable was that is the number of marriages conducted by the church at the time. And the correlation value was 0.95. Imagine. So what can be the interpretation? If you want to become immortal, if you want to increase the longevity of life, close the Church of England. But this is nonsensical. This is, or the exact word, this is spurious. The reason medical improvement is not considered, marriages is not considered, marriages are declining because of sociological reasons, and there is medical improvement because of which the death rate is falling. But we are not considering those things, but we have shown a relationship between two. So this is spurious regression. Now I define is, in time series, even if variables are I0, or at the moment you have not been introduced the concept of I0, so that is stationary at level, there can be a spurious relationship if the third variable is entered. If there are only two variables characterized by increasing or decreasing trend. Another problem is that even if x and y are not trending like pure random walk, we may get a significant relationship. So although there is there should not be any relationship, but because of an interplay of a different variable, these two are showing an element of relationship. So this is what we refer to as spurious regression. We will refer to another study by Granger and Bolt, but before that let us see that we take a pure random model. We have xt is equal to xt minus 1. What is today, what happening today is a factor, is just what has happened yesterday plus a random element. This is very applicable for stock market prices and all. Similarly, the other variable yt is equal to yt minus 1 plus bt. That is, today's value of yt depends upon yesterday's value plus a random element. There is no trend here. And suppose yt and xt are independent, and alpha and at and bt, that is the error terms of those two regressions, they satisfy all the classical regression classical assumptions, and we estimate the relationship yt is equal to b1 plus b2 xt. We test for the hypothesis, that whether we test for the significance of your element b2, and the null hypothesis is b2 is equal to 0 and b1 is not equal to 0. If your h naught is accepted, it indicates that xt and yt are independent. There is no relationship between these two, and so the standard testing process, t-test, will reveal lack of relationship between the variables. This is what we have studied in our initial classes on regression also. This study in 1974, Granger and Newbold, they found that even if xt and yt are independent, if we regress y on x, the level of significance is much larger than the conventional level of significance of either 1% or 5%, which we normally use in humanities, in social sciences. So it means, and he gave a rule of thumb that if r square is greater than the Durbin-Watson statistics, then think that something spurious is going on over there. So this study questioned this argument. Then in a related study by Davidson and McKinnon in 1993, it was found that in a sample of 50 observations and 5% level of significance, the hypothesis that b2 is equal to 0, that is the null hypothesis is equal to 0, is rejected 66% of times rather than 5%. Meaning thereby, even if x and y are not trending like a pure random walk, we may get a significant relationship. And the null hypothesis will be rejected not 5 out of 100 times, but 66 out of 100 times. That means there is a huge chance that we will get a significant relationship, although those two are not related. How they are not related? Xt depends upon xt minus 1 and a random term. Yt, it depends upon yt minus a random term. So there is no relationship between xt and yt, but still we will get a significant relationship. So the problems of spurious regression: high chance of getting a non-zero estimate even if there is no relationship. Estimates coefficients are misleading, that is the t-values, the significance testing is misleading. If correlation between delta x and delta y is also significant, then it is not spurious. But if the correlation between delta x and means change in x and change in y in the earlier case, if the correlation between delta x and delta y is also significant, then it's not spurious. But if the correlation between delta y and delta x is not significant, then you have to be careful that there is an element of spurious regression in it. So then finally we come to the last thing, that is strict stationarity. Strict stationarity is just we will not be discussing it anywhere else. Means that the joint distribution depends only on the difference h and not on time. Or you can say is said to be if the joint distribution of xt minus xt2 xtk is the same as xt1 plus h, xt2 plus h, xtk plus h. This is a case of strict stationarity, and we normally we do not consider, and it's not a real life phenomenon also, and it is not considered anywhere in your study of econometrics. We only consider the cases of weak stationarity. So today's lecture was, we did not it was not teaching you anything at the moment. We were just trying to make you familiar with the word difference stationarity, trend difference in the data, trend stationarity, stochastic data, and then spurious regression, then cointegration, and the main thing is stationarity and cointegration. Because nowadays in time series, maximum work is on finding a cointegrating relationship between the variables. These variables are such that there is an element of non-stationarity over there. They are a stochastic trend, and we cannot use our OLS method to estimate the results over there. There are chances that we will be getting a spurious regression. So what we have to do, the way out is we do cointegration over here, and cointegration doesn't exactly mean that this depends on this. As such, it is not that y is the dependent variable and x is the independent variable, and y depends upon x like what you have seen in regression. Rather, cointegration means that the two things are moving together, or they have, through which it implies that they have a long-term relationship. Hope you have got a feel of what are the things which you will be studying when you will be studying the topics of time series econometrics. With this, I end my lecture. Thank you. Goodbye.